we have to talk a little bit about chemical reactions with this unit. And so we just need to review some concepts that you've covered already in Science 9 and Science 10, specifically these two types of chemical reactions, which are called endothermic and exothermic reactions. Now, if you remember, when we break these words up, it kind of helps us with the definition a little bit. So we've got endo, which means in or to enter, and exo, which means to leave or to exit. And then thermic just comes from the word thermal, which means heat. And so here we have a chemical reaction where heat is going into the reaction or absorbed from the surroundings. And we have exothermic reactions where we do the opposite, that we have heat that's being released to the surroundings or just leaving the reaction. And so the best way that I like to illustrate this is with a little bit of a diagram / graph, okay? And so if I've got a graph here where I have energy on the y-axis and time on the x-axis, if I were to draw a line on here, this would show that over time the energy of a particular reaction is going up or down. So that's how this graph is kind of read. Now for an endothermic reaction, it turns out that before the reaction starts, the products have that much energy, somewhere around there, some defined amount of energy. Now in every chemical reaction, there is always energy absorbed. Now I know I just barely said that endothermic reactions absorb heat and exothermic reactions release heat, but this is only a net amount. For each reaction, there is an amount that's absorbed and an amount that's released. But for one reaction, it absorbs a little bit and then releases a whole bunch. And for another one, it absorbs a whole bunch and then releases a little bit. And so the net amount of energy absorbed or released is what determines whether a chemical reaction is endothermic or exothermic. So I take a look at endothermic reactions. In order for this reaction, for example, the formation of methane to occur, I have to absorb some heat. And the reason I have to absorb some heat is there has to be some energy that goes into the reaction to break the bonds of the reactants. So in this case, I'd have to break some bonds of the hydrogen molecules that are here, and that's going to take some energy to do that. And so when I put energy into the reaction, it's going to go up like this over time. Then once I have enough energy put into the reaction, and I start to form the bonds of the products, anytime that I form bonds, that's going to release energy. And so I form the bonds of methane, and then I have my products there. So my reactants and my products. And so you can see the net amount of energy for this reaction is energy in, or energy absorbed. And that's what makes this reaction endothermic. A couple of things to point out, and for you to make sure that you write down in your notes, is that we have two processes in chemical reactions. We have bond breaking, and then we have bond making. And so bond breaking, this requires energy. So when I break the bonds of the hydrogen molecules here, for example, that requires energy. So I have to put energy into that reaction in order for that to happen. And then I have bond making, where I'm forming the bonds of the products. And this, because it's an opposite process, bond breaking is requiring energy. Bond making, which is the opposite, is going to then require the opposite kind of process for energy in those reactions. So this is going to release energy. And so the analogy that I like to think about is if I have a stick in my hand and I want to break that stick over my knee, that's going to require some form of energy that I have to put into that stick in order to break it over my knee. And so that's how I remember that bond breaking requires energy. And once I remember that, then I know that bond making is just the opposite, which is releasing energy. For this exothermic reaction here, again, this process of bond breaking and bond making has to occur. But the amount of energy that's required and released in those processes is different. So for exothermic reactions, I have the reactants here, and I still require some energy to break the bonds, but it just doesn't require very much. And then once the bonds of the products start forming, I have a whole bunch of energy that's left over that's not needed in the reaction. And so the products only need this much energy in order to be formed. It only requires, or it only when I form these bonds here for the products, it only needs this much energy. Because I have that much energy in the reaction, then I've got a whole bunch of surplus energy that's not needed, and that is then released to the environment. So my reactants and my products are there. So if you take a look on this diagram, from here to here is bond breaking, A. And from here to here is B, which we'll call bond making, or forming of bonds. And it's the same over here in this reaction. This part, climbing up to the top of the mountain, requires a certain amount of energy, and then going down the other side of the mountain, you release all that energy that's been stored. And so we've got B there. So you can see for endothermic reactions, it requires a lot of energy to break bonds, not very much for exothermic reactions. But for endothermic reactions, we don't release a lot of energy when we make the reactants, but for exothermic, or when we make the products, but for exothermic reactions, when we make the products, we do release a lot of energy. And so it's this net amount that changes between the two.